Small heads, big intelligence. We are counting down the top 7 most astonishing displays of insect intelligence between bees and wasps. From unexpected engineering feats to mysterious communication dances, these moments showcase just how much can happen inside a tiny head. Each entry reveals a new level of teamwork, problem solving, or memory that will make you rethink what insects can do. Which clever strategy claims the #1 spot? Let us begin with number 7. A single paper wasp lands on sun-baked wood, antennae twitching. She dips her mouthparts into a water droplet, then carefully spreads the moisture across the grain. Within seconds, the fibers soften. Using her mandibles, she scrapes up the damp pulp and shapes it into a tiny ball. Other workers join in, each repeating the process. Some collect water, others chew and knead the fibers until they form a pliable paste. Back at the nest, these builders press the pulp into place, layering it with precision to form waterproof walls. The nest grows, cell by cell, each layer engineered to resist rain and wind. Every movement is deliberate, from water collection to the final press of a mandible. This is material intelligence in action, an entire colony transforming raw wood into a fortress, powered by teamwork and tactile skill. A single honeybee stands before a puzzle. A droplet of nectar sits just out of reach, tied to the end of a thin string. She circles, antennae flicking, then tugs at the string with her forelegs. The reward inches closer. She repeats the motion, each pull drawing the treat nearer until, at last, she sips the prize. This is no random fluke. Scientists have tracked marked bees through dozens of these trials, recording the rare individuals who figure out the steps. Most bees do not solve the puzzle on their first try, but some crack the code after watching a skilled demonstrator. In these controlled experiments, a few bees become fast learners, picking up the trick by observation alone. Each attempt reveals not just persistence, but a surprising knack for mechanical problem solving. While string pulling is not a natural skill for honeybees, these moments in the lab spotlight their capacity for flexible thinking and even social learning. These were traits once thought to belong only to larger animals. Tiny brains, big surprises. Number 5. Giant honeybee's defensive shimmer wave. A single ripple flashes across a curtain of giant honeybees. In less than a heartbeat, thousands of abdomens snap upward in perfect sequence, sending a shimmering wave from one edge of the hive to the other. Each bee moves on cue, triggered by the faintest shadow or a sudden shift in light. The effect is mesmerizing, a living tapestry that pulses in synchrony, as if the entire colony shares a single mind. Ultra slow motion footage reveals how the shimmer wave travels at lightning speed, covering the surface in milliseconds. No stings, no aggression, just pure breathtaking coordination. This wave is not just for show. It is a silent signal, a mass message that warns off would-be predators hovering nearby. The shimmer starts with a handful of bees near the disturbance, then spreads in flawless ripples across the colony's exposed comb. Every movement is tiny, yet together they create a spectacle that can stop larger animals in their tracks. Here, intelligence is not about outsmarting a puzzle or building a fortress. It is about the power of unity, encoded in a split-second dance of light and movement. A mud dauber wasp hovers at the edge of the cluttered rafters, antennae sweeping the air. She slips through a maze of beams and shadows, pausing to inspect each twist and turn. With every flight, she traces a mental map, remembering the best approach, the narrowest gaps, the hidden corners where her nest will fit. Researchers once dabbed her with a tiny dot of paint, then watched as she returned again and again, never losing her way even when obstacles were quietly shifted. If a familiar route is blocked, she reroutes with barely a pause, charting a new course through the chaos. Over days, her path grows more direct, each journey refining her memory of the space. Inside, she sculpts chambers from mud, each one tucked with precision among pipes and wires. This is not random wandering, it is spatial intelligence in action. The wasp's brain, no larger than a pinhead, encodes a shifting blueprint of her world, allowing her to navigate complexity with the poise of an architect. Each successful return is proof that even the smallest creatures can plan, adapt, and remember. A paper wasp hovers face to face with another, their eyes locked in a silent standoff. To the human eye, it is just a fleeting encounter, but for these wasps, every detail matters. Each face carries a unique pattern, subtle stripes, spots, and color patches. In the wild, these markings are not just decoration, they are social ID cards. Laboratory studies reveal that paper wasps can distinguish between individuals using only facial patterns, a skill once thought possible only in mammals and a handful of birds. In controlled controlled experiments, scientists present wasps with choice chambers lined with images of nestmates and strangers. Over repeated trials, the wasps reliably pick out familiar faces even after days apart. This memory is not just for show. Back at the nest, recognizing rivals or allies can tip the balance in dominance disputes, helping avoid unnecessary fights or forging new alliances. Macro close-ups reveal the wasp's compound eyes scanning, antennae flicking as they size up a neighbor. With brains smaller than a grain of rice, these insects store a social world's worth of faces, tracking relationships and reputations. It is a rare window into insect social intelligence, proof that even the smallest creatures can remember, recognize, and respond to the individuals around them. A honeybee steps onto the comb, body pulsing with energy. She begins a dance, tiny figure eights, a bold waggle in the center, then a looping return. Every move is a message. The angle of her path lines up with the sun's position, pointing her sisters toward distant flowers. The length of her buzzing run marks the distance, each second a silent measure of kilometers to fly. Around her, other bees press close, antennae quivering, reading the code with astonishing precision. Within minutes, new recruits launch from the hive, tracing invisible lines through open air, guided by nothing but the memory of a dance. Scientists have spent decades decoding this living language, confirming that bees use symbolic body movement to relay both direction and distance, an achievement once thought impossible outside the human world. Recent studies reveal even deeper layers. Young bees improve their accuracy by watching seasoned dancers, learning to fine-tune their steps through social experience. Each performance is unique, shaped by the dancer's age and history, yet the colony's collective navigation remains sharp. The waggle dance stands as one of nature's most sophisticated forms of non-human communication, a living map drawn with every step that turns a dark hive into a launchpad for explorers miles away. A shimmering midday heat settles over a paper wasp nest. One by one, workers launch into action, not for food, but for water. They dart to the nearest droplets, soak up as much as their mouths can hold, and race back to the nest's sun-baked comb. Each wasp deposits beads of water onto the exposed cells, spreading the droplets with swift, practiced movements. The nest's surface glistens, dotted with tiny ovals of moisture. As the water evaporates, infrared time-lapse reveals a dramatic drop in temperature, sometimes as much as 8 degrees Celsius in just a few minutes. The process doesn't stop there. Some wasps position themselves at the nest's edge, wings a blur as they fan the air. In certain species, this fanning draws cooler air over the wet surface, amplifying the cooling effect. But the real secret lies in how the colony responds to changing conditions. When the air thickens with humidity or the nest's heat spikes above a critical threshold, the pace quickens. Water collectors and fanners shift their positions, targeting the hottest spots. Others retreat to the coolest cells, pressing their faces against the chilled comb to protect their own brains from overheating. Every move is coordinated, each worker tuned to invisible cues in temperature and humidity. The result is a living air conditioner, an entire colony engineering its own microclimate, cell by cell. This is environmental problem solving on a grand scale, powered by hundreds of small heads thinking as one. No single wasp controls the process, yet the colony maintains a stable, safe environment for its brood, even as the world outside sizzles. In the world of insects, this is the pinnacle of group intelligence, adaptation, teamwork, and environmental mastery, all woven into the rhythm of a summer afternoon. Across all 7 moments, one pattern stands out. Bees and wasps turn simple instincts into complex, adaptive solutions. Insects with tiny brains achieve feats of teamwork and engineering that rival much larger animals. Intelligence in nature is not about size, it is about how life meets its challenges. Nature never underestimates small minds.